are you, everybody who is watching this fantastic video? I'm very happy to have you today, and I would like to welcome you. You are in the right place for the rest of your life. If you are an advanced student, believe me that you'll get connected with me. And if you take the category of engineering, we'll be meeting together and we'll be meeting different aspects of life, because we are here in order to impact the life of other people's. My name is OLENJOLAI Moko Tayego Singo. Simply just call me Sir and the engineer OLENJOLAI. I'm a teacher of advanced physics. I'm from Tanzania. I'm a Tanzanian. I'm from Tanzania, and I thank God who have given me a gift of teaching, and especially He has given me an assignment to teach advanced physics in a national level. So simply, I'm not maybe a local school teacher or particular schools. I'm not working with any schools at this moment. I used to do. Right now, I'm a national advanced physics teacher, a national advanced mathematics teacher, a national advanced chemistry teacher, a national basic applied mathematics teacher. So wonderful. I'm not boasting about myself. I'm just telling you about the position that God and Hannah has given to me. I will give all the glory and praise to Him. So I would like to take this opportunity to welcome you, whether you're a national or international viewer. I'd say you have to stay tuned and you have to stay focused. I would like to take this opportunity to welcome you into one of our online schools, not a physical school. That is called Tanzania Online Advanced Secondary School, in square bracket OLENJOLAI M. So M with the other meaning, this is the name of the person, very important person in my life. OLENJOLAI is my name. So if you want to know the spelling and how you can pronounce my name, just see OLENJOLAI. This is M, it's a name. It's a name of a very important person. Simultaneously, because I'm teaching basic applied mathematics, advanced and basic applied mathematics, I'm also teaching advanced mathematics. I would like to welcome you into one of our YouTube channels that's called the Tanzania Online A-Level Circuit School, in square bracket OLENJOLAI M. Wonderful enough, I know that you are you're a teenager, maybe you're a parent or a guardian or a sponsor. Listen this information and deliver it to your children who are in advanced level. The primary question that comes in your mind: what are we doing? What the vision that we have in Tanzania Online Advanced Secondary School? That's a very good question. It's a right question to ask us, I know. So that's why that God has sent me to answer. So we have an assignment to teach and train some students by using different teaching aids and teaching techniques, who will be ready to extract knowledge and wisdom from the advanced science subjects and advanced mathematics, and combine with the knowledge of the Word of God written in the Holy Bible in order to solve real life problems. The main objective of Tanzania Online Advanced Secondary School is to see our continuing student and even our graduating students solve at least a single real life scientific and mathematical problems, because not every problem is scientific and not every problems need mathematical solutions. Some of them they need just police. For example, in case of the laws and whatever, so it's just making a police, and then politicians are there to do their responsibility. I know possibly that you have been roaming around as advanced secondary students or second year in advanced education. You have been stressed out on how you can master the subject of advanced physics. You've been given up, possibly have tried different alternatives. You've used the materials which have been given by your former teachers at the school. You've been using different materials or you have been reading different books. You've been going online, finding help for the advanced physics in Tanzania educational system. Possibly you've been studying day and night, but you didn't make it. You find that as days goes, and when you get into the second year, which you call the Form 6 level of advanced education, then your hope in advanced physics getting lower and lower. Possibly you have given up that, okay, whatever the case, I will make sure that I have to make sure that I don't score F in physics. So I would like to add to give you an advice that don't reach into such kind of the final destructive conclusion. You have never tried to learn in Tanzania Online Advanced Secondary School. believe me, whether or not, in these online schools, we'll try our level best that will make our students to understand and enjoy the beauty of physics. Even if you forget everything I said, remember that joining Tanzania Online Advanced Secondary School in square bracket OLENJOLAI because I want to love advanced physics, I want to understand advanced physics, and I want to enjoy the beauty of advanced physics. This is session 2. We have, for in case of the chapter which I've written there above, we have prepared more than 20 sessions that we are going to teach you about current electricity. So that is a very important point. Let me talk about the last thing, then we are going to start to start our session. Whenever you join any physical school, physical advanced secondary school, the first thing you face is registration. How can you register into the Tanzania Online Advanced Secondary School? Because this is the online schools. You just access the contents online by using the internet. We don't have any physical schools. And then the first thing, you should have have an email. Have a Yahoo or Gmail email. That's the first thing that you need to have. Just within a minute. After you have your email, the next thing, sign in YouTube. So sign in your YouTube. Okay, by using your OT, by using your email. By using your email. The third step, click the buttons on the right at the bottoms of right hand side of the video you are watching right now, which has been written subscribe. Once you click, then it changes into the past tense subscribe that you have done. Why should you subscribe? That's a very important question. The aim for you to subscribe is in order to be permanently registered in our YouTube channel as online resource, as online school, advanced school. So when you subscribe, whenever we have a plan, a picture, God has given me a picture to prepare more than 500 videos that will be teaching about advanced physics, advanced chemistry, advanced mathematics, and basic applied mathematics, Form 1, Form 5, and Form 6. So 8 subjects which has to be taught by 8 teachers. But God is faithful, has put everything that you need in a single man called the teacher OLENJOLAI. But remember that OLENJOLAI does not know everything about advanced physics. I don't know everything. I just know a small portion, but I have an assignment to teach others what I know. I'm always learning advanced physics. Remember that for the rest of my life, because there is no end of learning and there's no end of knowledge. So the end is if you departure, then others, what you find the discovery is get continued. So please, I ask you to subscribe, and once the icons of the bell appear, click and choose the option of all. That is now you are a student. You have to make sure that you have an access of internet, and you get into your internet when you finish your classrooms or your regular sessions. If you're a day student, a day school student, if you're a government school student, access this content during the holiday, okay, and during the weekends. So I think that that's enough. Let me take you into the beauty of what we have prepared today. So we are in departments of advanced physics where we are teaching you 2 subjects, advanced physics for the Form 5 and advanced physics for the Form 6. And then we have a subject today of advanced physics for the pre-Form 6 and also for the Form 6 students, or class 14s, or high school students, or advanced school students of the second year. We are learning chapter 2 that's titled Current Electricity. And this is session 2 also, that's titled as What is Current Electricity? So the title of the today's session, I'm not a traditional teacher. I'm a very exceptional teacher. I think differently, and I will teach you how to think differently. And always, I used to teach from the big picture. And my teachings, I used to arrange the content sequentially from the fundamental concept to the intermediate. Then later on, we get into advanced and complex ideas, but we simplify the complex ideas in a very simple language. So don't hesitate yourself, let us go to today's business. So just to do the quick review of what? Of session 1, just to link session 1 and this session 2 of current electricity. So in session 1, basically, first of all, we shared with you about big picture of physics, okay, big picture of what? Of physics from what? From science, right? Which I'm going to repeat right now, but now it's perspective of electricity. Then I shared with you about what? About the contents, means about the subtopics. About the subtopics of what? Subtopics of current electricity. C8 abbreviations of current electricity. Then I presented to you about specific objectives that have been recommended by the syllabus of the United Republic of Tanzania. I have a syllabus here in my hand. This is the syllabus. It's called the Advanced Physics Syllabus it's called the Physics Syllabus for Advanced Secondary Education from 5 through from 6, prepared by Tanzania Institute of Tanzania Institute of Education. So United Republic of Tanzania Ministry of Education and Vocational Training by that time. Nowadays the names have been changed. Okay, so printed by the Zombe Book Pro. Okay, those are the others. Relevant stories. So specific objectives of what? Of each subtopic. Each subtopic has its specific objectives according to the syllabus. Next, I shared with you about concepts. Okay, I presented to you about concepts or contents of what? Contents of what? Of current electricity. And I say that this one, every teacher developed his own contents and they arrange according to the logical way, in such a way that students, they won't get confused, but they will get help when they go through it. So today, in this, before I go into the fundamental questions of what is current electricity, ladies and gentlemen, I would like to give you or to share with you the big picture that God has revealed in my mind while I was preparing or I was meditating about electricity, because I'm an electronic and telecommunication engineer. So what I'm teaching actually is what I'm applying practically in my daily life, because another gift that God has given me is to be a unique electronic and telecommunication engineers. Simply, or you can call it just a unique electrical engineer and computer scientist, and a unique computer scientist. So that's a gift. That's what God has built in me. Just like swimming, it has been built in fishes. So when a fish is working, is when it's swimming. So for me, when I'm teaching, it's just like a bird that flying, because flying has been built in birds. You have never seen any birds learning on how to fly. Similarly to me, the issue, the techniques, and the style of teaching, it's difficult for a person to teach me, because every day I have a new discovery I receive from my manufacturer, who's God himself, Elohim, El Shaddai. Okay, so the big picture of what? The big picture of electricity. Okay, for electricity. So let us start from the big picture. First of all, the mother of electricity is science. Then, if you do remember that in my previous session, we say that science also breaks down to form 3 branches. The first branch is called the biology. The second branch is called the physics. The third branch is called the chemistry. It's called the chemistry. So you have these 3 branches. Then in physics, we have O-level physics, and also we have advanced physics. Okay? Advanced physics. So we are looking where can we get to the subject of current electricity. So in physics, we have what? We have O-level basic physics. Basic physics, and this we cover in O-level. Okay? And also we have advanced physics, ladies and gentlemen. Advanced physics. In basic physics also we have a topic that we teach for 2 students that call it current electricity. But here we are focusing in advanced. So when you go into advanced physics, we have so many topics, but if we refer according to what the Tanzanian syllabus of advanced physics recommend, the first branch of advanced physics is called mechanics, which is classical mechanics. Then the second branch of physics is called heat, which actually are focused about a branch of physics called thermodynamics. The next one is called the wave and propagation. The next one is called what? Static. Now we have what? Electricity. Okay? We have electricity. So electricity in general. Then the next branch is called what? Magnetism. Electromagnetism. 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 Okay? Electromagnetism. But another topic is called the atomic physics. Atomic physics. Another one is called the electronics. My beautiful topic there. Okay, electronics. And then the last one is called geophysics. Geophysics. So simply 1, 2, 3, 4, 5, 6, 7, 8, 9. So possibly at 9, I think there are 9 topics which are there. Isn't it? Yeah, I think so. There are 9 topics. Okay? Let me check in. I'm not sure. Did I mention about geophysics? Yes, we have atomic physics. Yes, we have environmental. So this is called environmental physics. Yes, that's why I was worried about. So 4, so you have 1, 2, 3, 4, and then plus 5. So this is environmental physics. So it's called environmental physics. So how many main, this we call them main topics. So we have 9 main topics. Here we have 4 main topics because we are going to classify 4 main topics we have to cover during the first year of high school. It means Form 5. And also, so this is all about Form 5. And when we get into electricity, this is the second topic. Then we have to cover these contents during our Form 6. We have 5 topics. But here this is the longest topic than all. So now, so we have the word electricity. So we have to, so this is the electricity. Okay? So if we take the word electricity, we break it down. Okay? We break it down into 2 branches. Static electricity, which we taught you during your Form 5. So it's called static electricity or electrostatic electricity. And then we have what? Current electricity. So this, the big picture should be in your mind. Current electricity, where we are. So if we take this subject of current electricity further, okay, current electricity, then we can find, so current electricity, we can find another division which we are going to focus on in this second chapter, and these kinds of division is according to the direction of 40, based on the directions of electric current. So we have dielectric current. This in short we call it DC. Okay, DC means it's one directional, and also we have alternating current. So alternating current. So we have alternating current. So this is all about AC. So that's all. Those are the 2 branches of current electricity. So right now we are here and we discuss with this first topic, and then we'll go into this second great topic and very important. Okay, so ladies and gentlemen, that the big picture should be in your mind. So when we are learning about current electricity or static electricity, you should know the origins of what. Because, for instance, if somebody asks you, I know that you used to answer during your form, what is physics? Physics is a branch of science which deals with what? With the study of what? of nature and properties of matter and the energy and their interactions. That's the meanings of physics. So it means that even current electricity should relate with the definitions of physics, because the word physics comes from ancient Greek, which means that what nature. So it means that you're studying about nature, and electricity is a very important source of energy. So ladies and gentlemen, right now let us go into the overview or the fundamental knowledge of current electricity. And I would like to write a very important word, and I call that this is a key word for this second chapter, which we call the electricity. So ladies and gentlemen, this is the first question, fundamental questions for Sir OLENJOLAI. What is electricity? Ask yourself. Pause the video and let's answer this question yourself. If you are watching these programs as a group of students, then after you ask yourself, then you ask your neighbors, what is electricity first? Before we learn about current electricity, what is electricity? All right? There are so many definitions of this word electricity, okay? But I have found one of the definition that called the electricity, or that define the term electricity, okay? So say electricity okay? Electricity simply, we say that, is a branch of physics. Simply is a branch of physics. Okay, it's a branch of physics that deals, is the simple definition, deals with the study of what? Of electric charges such as electron at rest, and at motion. So this is the simple definition of what? Of electricity. It's a branch of physics which deals with the study of what? Electric charges at what? At rest and in motion, not at, in motion. So simply, whenever we are dealing with the study of the charge when they are at rest, which we call it electrostatic, okay? Or we call it static electricity. And when we are dealing with charges in motions, which is called what? Current electricity. Both of those branches, that's what we make electricity. This is one of the definitions. So let me give you the second definition of electricity. Okay? Electricity is a set of physical phenomena. It's a set of physical phenomena. It's a set of physical phenomena associated with the presence of what? Is the presence and motion of matter. Is the presence and the motion of matter that has a property of electric charge. That has a property of electric charge. So electricity is a set of physical phenomena. So this is the state, it's not one physical phenomenon, it's the set of physical phenomena with the presence and motion means that charge at rest, charge in motion. Or 40, motions of matter that has property of 40 electric charge simply. So simply, ladies and gentlemen, just to clarify, we say electricity is the branch of physics that deals with the study of electric charges at rest. So whenever we study electric charge at rest, that's one of the branch of electricity. And also electric charges at what? In motion. All right? Or in other words, or other resources, electricity is a set of physical phenomena. It's the study of the physical nature. Associated with the presence means that presence of the charges in the matter and the motion of what? A motion of matter that has a property of electric charges. So in electricity, basically we are focusing on what we call them just those matters which can store charges, and also we are focusing on matters which can allow these electric charges to flow, right? And these electric charges, we call them electrons and the protons, or electrons and ions, and the protons. Those are we call them current carriers or current conductors. So those are the two definitions of what? Of electricity. Some of the sources, they use to define electricity with the focus of current electricity. Remember, electricity is not what? It's not current electricity, but this is a big picture of electricity. Again, we say that according to the different sources, electricity is the second largest thing. So we say that, just to give you the overview, say it's a secondary energy source. Electricity is a secondary energy source, which means that we get it from the conversions of other sources of energy like coal, natural gas, oil, nuclear power, and other natural sources. Let me write this word. Because for the definitions, okay, you can look for other definitions. Electricity, the flow of electric power or charge. Electricity, the type of energy that can build up in one place or flow from one place to another. So let me give you the same definition because I love you so much. You are my beloved student. Okay, tell your neighbor you are being loved by Sir OLENJOLAI. So electricity, we say that is a type. Remember that physics is the study of what? The study of nature and properties of energy and what? And matter. So it's a type of what? Of energy. So it's a type of energy. It's a type of energy that can build up, in one place. That can build up in one place, or flow from one place, to another place. So if we examine or we review or we reinforce to understand this definition of electricity, say the type of energy. So we have different energies in physics, because physics is a branch of science that deals with the study of what? Of nature and the properties of what? Of matter and energy. So the type that can build up in one place. So build up in one place means this is charges at rest or flow from one place to another place. So either charges, they can build up and be stored in just in a certain conductor. For example, a capacitor store charges, and hence also charges they can be transmitted. Okay, so after giving you definition of this, I would like just to write this one. Electricity is very strong sentence. Why are we studying electricity first of all? Electricity, we say that we taught you static electricity during your Form 2, the first chapter of Form 2, and current electricity during your Form 3 education. So we taught you these two branches of electricity during your O-level. We are not going to repeat all those stuff. We are just giving you the fundamental, reminding you But believe me, in the next sessions, in session 2, you are going to examine or you are going to learn new concepts about electricity. So electricity is the secondary. Okay, it's a secondary large source of energy that can be. So this is the secondary. So what the primary? This is the secondary. What the primary? Okay. So the literature states that it's a secondary energy source or source of energy. Okay, that we get it. That we get from conversion of other sources of energy, other sources of energy, like what? Like coal, like what? Like gas, natural gas. Okay, natural gas, and so what? Got oil, and what? And nuclear power, and other sources, nuclear power. For example, solar. Also, you can get it from solar energy, oil, solar. So here you can say also solar, and nuclear power. So for seals, we have so different sources. So we say that we can get electricity from conversion, because remember, according to the we call it the law of conversions of energy. Energy cannot be created nor destroyed, but it can be transformed from one form to another form. So it can transform, it means we can convert chemical energy into electric energy. So let us see these sources. For example, coal. Some of the countries, they use electricity from coal. Then we have natural gases. For example, what is the source of electricity in Tanzania? So we have possibly more than 2 sources. One is natural gas, right? From the songas, that's called the songas, or just produced by the companies that call it songas. And then oil, it means that, for example, generator. So you have productions machines that using the oil. But also you have solar panels. Solar panels are the source of electricity. We don't have electricity come from nuclear power in Tanzania. So, but in some of the countries where they have nuclear, they have electricity, or one of the source of electricity is nuclear. Okay? Then we say branches. So the next concept that we have to give you for building your mind, branches of what? Branches of electricity. Branches of electricity. So simply say that there are 2 branches, main branches of what? Of electricity. These are, the first one is what? Static electricity, which we discussed before. We told you during your formal education. And the second one is called the current electricity, or electric current. Remember this start. Yes, click this button for you to get notification. Right. So static electricity, and the second branch is called the current electricity, or in other words, we call it electric current. Electric current. So Don't need static electricity, the branch of electricity which deals with the study of charges at rest. Let us have a focus on current electricity and let us answer the question we have asked above. The question we have asked above is what is, this is second question. What is current electricity? What is current electricity? That's a very important question. What is current electricity? You can pause the video and ask yourself. And also you can pause the video and ask your neighbor, and you ask your neighbor to define what is the term current electricity. So I have found some of the definition. Let me share with you. The first definition is the word current electricity is a stream. Is a stream of what? Is a stream of charged particles. The stream of charged particles such as electrons or ions, moving through an electric conductor. Example, a wire. Example, a human body, an electric conductor, or moving through the space. It means that, as I said, we have a subtopic called the conductions of electricity in gases. So current electricity is a stream of charged particles. So it's a stream of charged particles. It can be positive charged particles or negative charged particles, but the most common one is what? Negative charged charged particles, which are electrons. But also ions are good conductors of electricity. For example, in case of dry cells or in case of batteries. For example, your cells, your mobile, your cellular, your cell phone's battery. It means the battery of your phone, the battery of your computer. All of them are conductors of electricity according to what? To ions. When electrolytes ionize, according to the first and second Faraday's law. Moving, so these electric charged particles have a tendency of moving through electric conductor or space. So it means simply current electricity is it's a branch of electricity which deals with the study of charged particles. Study of the charged particles, study of the motion of charged particles in the conductor. So we're a conductor or space, okay? So this is the full stop. Or another definition of is a branch of physics which deals with the study of the charges in motion. Okay? Current electricity. Current electricity, you say that is a branch of what? Branch of electricity that deals with the study. Maybe just like a revision for you if you have taken my session during your O-level education, but stay connected. So we are going to get into new concept for all advanced secondary education students, for all advanced secondary students who are studying physics. Current electricity, the branch of electricity that deals with the study of 40 of charges, study of charges in what? In motion. In motion. Study of charges in what? In motion. So that the definitions of what? Of current electricity. Simply this is the study of what? So we say that it's a study of the charges in what? In motion. Right? So that is very important. You can also even find the other definition. It's fine. You're not going to be have peace in that. So we say that we have what? So in order to start the motions of the charges, first of all we have to know how we measure the charges. So the next term which we have, I think that this will be this was the second term. The first one was electricity. The third term, we say that we want to remind you about coulombs. Coulomb. Okay? About Coulomb. Because very important for electricity. Have to remind about 30 Coulomb. Okay? Coulomb. Say Coulomb. In a simple language, you can say that a Coulomb is the essence of quantity of charge. Or it's the essence of the charge. You are right. But you have to be careful when you're defining the word Coulomb. Coulomb. So the third question is, what is Coulomb? What is Coulomb? Okay? You have so many definitions of this thing, but you say that Coulomb is the quantity of charge in an electrical conductor. In an electrical conductor, we teach about good conductors. We teach about conductions, means that conductions of metals. In an electrical conductor, which causes, so this is the one that causes, what causes the flow of electric charge? It's this Coulomb. So quantity of charge, okay, causes what? Current of 1 ampere. Right, just like this one. Current of 1 ampere to flow. Flow in what? In 1 second. In 1 second. That is the meaning of Coulomb. So Coulomb is the quantity of charge in an electrical conductor. So this is the quantity of charge in an electrical conductor. And the functions of the quantity of charge, they cause they cause current of 1 ampere to flow. In what? In 1 second. So within 1 second, if you have 1 Coulomb in a metal conductor, right? In your metal conductor or in a good conductor, for example, then 1 Coulomb will cause 1 ampere to flow from one point to another point through the conductor in 1 second. So if that's the case, we can have something to mean that, okay, the relationship between current and and time. So, but also we say that, remember, just to remind you, Coulomb is an SI unit of of charge, of electric charge. electrical charge. And if you do remember that this is donated as what? Capital C. So it is donated as capital C. That is one of the key points you have to remember. So from this definition, you have also to remember the formula. You say the quantity of charge is equal to current times what charge. The meanings of 1 ampere flows through the electric conductor in 1 second, then we get the quantity of charge. So that's the product. So remember that I, so you say that I, this is equal to electric current, or current electricity, electric current, and then T stands for time. Stand for time. Okay? So that's very important formula. We are going to recall it soon. Because also you have to recall the formula that gives us a relationship between quantity of charge and voltage and the number of electrons present in the electric conductor. Electric conductor. Say also, so it means that if quantity of charge is equal to current time, this is question 1. And then we have quantity of charge is equal to number of electrons times electronic charge. This is question 2. Okay? So we say that second step, that the first step. So this we have covered them during our study in all of education. So the second step, going to question 1, we see question 2. So then we find number of electrons times electronic charge is equal to current times time. So we can make the subject, we can divide by electronic charge. So we have number of electrons of electronic charge is equal to what? Okay, we have number of electrons. This is equal to what? Current over electronic charge times what? Time. Divide by time both sides. So say number of electrons that will be passing through the conductor. This will be given to the current or electric current that flows through the conductor of electronic charge. So this is very important expression that we will discuss it in detail later. So number of electrons per unit, that will be, so number of electrons that will be flowing from one point to another point of electric conductor. Okay, is equal to electric current or voltage over electronic charge. Okay, so that is very important term. Just to remind you, the SI unit of electric current or current electricity. So SI unit of electric current is called the ampere. Current is called the ampere. This is the name of the physicist who did the experiment on electricity. So you know the convention that 1 ampere is equal to 1,000 milliampere, and that's what you have, and also 1 ampere is equal to million microampere. So it depends that you are converting it into what magnitude. Okay, so that's very important key point for the rest of your life. Okay, so again, just to introduce, as we said, that if you have current, electricity, then you say itself divides into 2 branches. If you do remember, let me repeat it. Okay? So current electricity, we say you have 2 branches. First branch is what we call the direct current. So this is the conductions of electric current when flowing through the conductor, electric conductor, flowing through electric conductor in only one direction, at the means of what is electric current. When you have alternating current, this is the current that when it is flowing through the conductor, it's alternating in its direction. So it's called alternating current. Alternating current, which is AC. So the good news, we are going to cover, and I'm going to teach you both branches of current electricity, which are called direct current and alternating current. So we are going, when we learn about conductions of electricity in metals or in gases or in different aspects, then I want to tell you that we are focusing on direct current. So the first part of this chapter is all discussion about current, about direct current. However, that we won't call it direct current, will be just called the current. But when it comes to the alternating current, then you have to include the alternating current. We have also varying current, but we'll be discussing later. Right now, we are keeping in mind that we have direct current and alternating current. That possibly alternating current is the new concept in advanced education. But direct current, we have discussed it during our O-level studies. Okay, so if that's the case, you say that the first part of this, the first part of current electricity, the first part of current electricity is direct current. So from today onwards, we'll be discussing about direct current first. And then the second part of 40 of current electricity or electric current. Electric current is what? Is alternating current. Alternating current. We are going to teach you also about AC theory. And you'll enjoy. And you'll master it. So that's the way that the syllabus is arranged in content about current electricity. Okay, so ladies and gentlemen, we have again another key point that we have to remember. So if that's the case, we go for the first terminology of the day, which is called direct current. Direct current. So this direct current is what you see. So we have the fundamental question. What is direct current? Pause the video and then ask your neighbor. Remember that in this first session, I'm building the foundation in your mind. I'm building the foundation. Tell my neighbor that OLENJOLAI is building the foundations of electricity in my mind. What's the direct current to the C? So say that direct current, or in short, the famous name is AC. We say that is a branch of what? Of current electricity. Of current electricity, which what? So which flows in only one direction. In only one direction. What does it mean? Example, if you have a conductor, suppose that this is the wire, conductor that has a certain length to the point B, so we have a certain length for this one, which you can call the hour. And then you say that, for example, if you have direct current, we connected the positive terminal here. So the directions of direct current will be flowing from A to B or B to A, depends. If I connect a source here, positive sign or positive of the battery, then this will be negative of the battery. So current will be flowing in from point A to B. If I connect on this side, then current will be flowing so be from point B to point A. So also from this concept, we find that in case of a say that again we have not this one. The direction of electric current, you have to remember always, the direction of electric current in electric conductor is always opposite to that, to the flow of what? Of electrons. That we call them current carriers. So you say that these directions of current. For example, if the current carriers in conductor AB, for example, it is copper wire, because copper is a good conductor of electricity. So in case that, or just difficulty of the silver constant wire, that's all. So you say that if you want to show the flow of electrons to be opposite direction, so this is the directions of 40 of electrons. So electrons flow in opposite direction to the directions of 40 of electric current. So that's another point that we have to note as physicists. So let me again introduce to you about current carriers. Current carriers. So the fundamental question is, what is current carriers? Give examples. So current carriers, we say that are the particles or as a subatomic particles that are responsible Conductor is responsible to conducting electricity. The good example of current carriers is what? Example, electrons, which flow in opposite direction in the directions of what? Of directions of what? Directions of current. In electronics also, semiconductors carries electric current by using what? By using holes which are positively charged. Okay, so ladies and gentlemen, let me end this session here so that you can join me in the next session where I will take you in too much details and we'll be focusing on the technologies that we use in electricity, but also we'll be focused on conductions of electricity in metals and then start enjoying the beauty of what for advanced physics. So the point that right now I would like just to make is what this is example 1. Example 1. This example 1 to say that define the following terms. This homework will prepare you for the future. Find the following terms. The future session. Define the following terms. Resistance. Voltage, drift velocity, Then the next one, how to define about what is current density. Current density. And then the next terminology. Conductance. Okay? Conductance. And also define the term ohms. You know all of these terms, possibly, except maybe velocity and current density might be a new one. It's not about conductance, ohms. So you know most of these terms. So this is Roman 1. Okay, so that's the homework, and that's example 1. So this is homework. So we have to do exercise. Homework 2. Okay, so ladies and gentlemen, this is the end of our today's session, which is session 2 of what is current electricity from the chapter 2 or second chapter of what is current electricity. Thank God who have created me in his own image and likeness, and thank God who have built me in his own image and who have given me a gift of teaching. I believe that you've understood what I've been teaching. In case you have any question or any confusion or anything else that you didn't understand, just go there and then write for us below there by using your own note, by using the comment sections that you will find in the YouTube platform. So Thank you, the national international students. I believe that you have enjoyed this moment, and I would like to invite you into the next session, which will be session 3, and where we are going to focus on the different issues or different technologies that you have to encounter as students. So make sure you do your homework. Remember to subscribe. Remember to enjoy the beauty of advanced physics, and stay focused and stay as a man or a woman with great vision to impact the present and future community. So I will keep on praying for you. I ask you also pray for me, because really this business needs boldness. So I thank you very much. Thank you very much. May God bless you abundantly. And this is Sir and Engineer OLENJOLAI from Tanzania, from beautiful Tanzania, who has been teaching you about advanced education in Tanzania. So may God bless you abundantly until we meet together at this place. Never expect it to miss. Invite some of your colleagues so that they might get what you are doing. So may God bless you abundantly, my beloved student. Let us meet again in the next session 3. Be blessed and kept by God Himself.